Now, since we don't have like a real formal chapter on troubleshooting for this class, I do want to give you a lesson on what I would say basic troubleshooting. Then I'm going to jump into some other things on like troubleshooting some IPv4 and IPv6 stuff. I'm going to do a little bit on troubleshooting wireless LANs and troubleshooting interVLANs with you as well, just so you have a good roundabout way of hitting all the different things. This piece right here, this screen right here, is the basics of all troubleshooting altogether. Network problems themselves, they can be simple, they can be complex. It can be hardware, it can be software, it can be network issues, it can be routing issues, it can be switching issues. Your job is to identify that problem. Okay, the first step in troubleshooting is to identify the problem. While tools can be used in this step, a conversation with the user is probably where you're going to get the most information. The hardest thing that you're going to have as a user, or I'm sorry, as talking to the user, is talking to them without insulting them. Don't make them feel as though they are the cause of the problem, even if they may be. Um, Many cases when you ask somebody, well, what did you do? They're like, I didn't do anything. I didn't break it. It wasn't me. Um, so you have to come up with a methodology and just follow these 6 simple steps. It's based on a scientific method, um, really. Assess the problem. Talk to the user or ask them questions. You know, I know you didn't cause the problem, but can you tell me what you were doing before it happened? It might show me that there's a network bottleneck or something like that. Always kind of like throw in another statement to, uh, keep them off the hook, so to speak. You want to then come up with a theory of probable cause. Okay, so after you've talked to the user and you've figured out what the problem is, okay, now you need to come up with a theory on what might have caused the problem. Is there a memory leak? Is it a memory issue? Is it an application issue? Is it a networking issue? Okay, this step would give you some causes to the problem. You don't want to fix the symptom, you want to fix the cause. Okay, then based on what you came up with, what could be causes to this problem, you want to come up with a way to determine which one of the ideas you have is actually the problem. Okay, so if a quick procedure does not correct the problem, then you might need to research the problem a bit further and establish what could be the next cause. Okay, after you've figured out, what could be causing the problem, now you need to come up with a plan of action to resolve the problem, and then implement that solution. So after you've determined what the problem is, what is it that we can do to fix it? And more importantly, or equally as important, when should I fix it? The last thing you want to do is go work on an intermittent network problem that's affecting 1 or 2 users and bring down 500 users because, these 2 users want to fix now. So come up with a solution and then verify full system functionality and then implement measures later on to keep them happening again. So once again, you come up with the cause of what could be causing it. You've come up with a possible solution. You've now solved the solution, then you've tested it, and you've made sure that the users are satisfied. And then say, okay, well, this is what caused my problem. I'm going to implement this to keep it from happening again. And then document. The final step for every troubleshooting problem is always going to be document, document, document. Okay, it's a very important part because later on, 2 years down the road, you might end up with that exact same problem again and not know what you did to fix it. So it's always important to do that, to document. Now, there are times when perhaps maybe you couldn't fix it. Okay, maybe the problem couldn't be fixed, right away. Maybe it couldn't be fixed by you. Maybe you don't have the privileges as a network technician. You might have to move up to a manager. So could you resolve it? And if you can't resolve it, then you escalate that problem to level 2, level 3 support, depending on your company's infrastructure. Uh, Did it work? Can you fix it? Well, one of the things you always want to make sure that you can do, verification tools means you want to ping, you want to trace route, you want to use show command. The ping command can be used very successfully. And the problem that I see a lot of people have with pings is they don't know all the different answers for ping. So if you have a general transmit failure on a ping, then you should understand that that means you don't have your default gateway set correctly. That means you're trying to ping a device on another network and it doesn't know how to get there. So there's just a general transmit failure altogether. A failed ping doesn't always provide enough information just to draw any conclusion. It could be the result of an ACL being wrong, a NAT being wrong, firewall blocking ICMP packets, or the destination device just may be configured not to respond to pings. So not all devices will kick back your pings. Okay. Trace routes give you a way to find out where the break might actually be in the line. Okay, it's useful for displaying the path that packets are using to reach a destination, while output from a ping command shows whether the packets arrived to the destination. Output from the trace route command shows what path it took to get there or where the packet stopped along its way. And then when you're working in your routers, don't forget the show commands. You've got show IP interface brief. You've got show interface. You've got show access control list. You've got show run. The show commands are some of the most useful troubleshooting tools we have when we're working on our systems. Okay. Taking advantage of a large variety of options and sub options, the show command can be useful in narrowing down and displaying information about practically any specific aspect in the iOS itself. Here you can see we did a show IP interface brief. You'll notice that the two interfaces that are configured with IPv4 addresses are both up and up. That means these interfaces can send and receive traffic. And the other three interfaces have no IPv4 addresses and they are administratively down. What a lot of times we tend to forget is that interfaces on routers are administratively down by default, and interfaces on switches are. Okay, now in this class, we have done considerable work with inter-VLAN routing. Routing on a stick in particular. And what I want to cover here are some common troubleshooting techniques that we should go over for troubleshooting your inter VLAN routing itself. So by now, you know that when you configure and you verify, you also got to do a little troubleshooting to make sure it all worked. There are a number of reasons why an inter VLAN configuration might not work. They're related to connectivity issues typically. So you want to first check the physical layer, make sure it's all plugged in. Make sure you have the right cable. You have a crossover cable when you're doing switch to switch. You have a crossover cable if you plug the PC directly into the router. Straight through cables where they need to be. That's always the one you want to make sure. If the connections are correct, next one we want to check is to go through like commands on this table to find out what could be wrong. Okay, if you don't have VLANs in there, okay, well, go in and create the VLAN, make sure it exists. How do you know if it exists? Do a show VLAN. You can do a show VLAN brief if you want, or just show VLAN. The output of a show VLAN really isn't that big. Okay, show interfaces switch port. Okay, to make sure that the host ports are assigned to the correct VLANs. And then obviously you want to ping if you can. Okay. A lot of times I've noticed that VLANs are all set up, but that is not getting to and from the router. Usually it's a trunk port. Remember, trunk ports are used to carry data from multiple networks on one line. So ensure that your trunk port has been configured correctly. So you'll just do a show interfaces trunk, or if you wanted to, you could actually do a show running config. Okay. Switch port access. I've seen this a lot with phones. Okay, switch port access. You could do a switch act. If you have your switch port assigned to a VLAN or the wrong VLAN, or you have your phone on the data VLAN, or vice versa, you want to make sure that you have the right switch port access. So assign correct VLAN to the access ports, ensure the port is an access port and it's enabled. Make sure the host is check to see if the host is incorrectly configured, if it's in the wrong subnet. Do your show interfaces switch port command, your show running config interfaces command, do IP config commands. Okay, find out what your computers have going on. You also want to look at just your standard routing configuration. Router sub interface IPv4. Make sure your addresses and your subnets are right. Okay, and that your interfaces are all assigned to the correct VLAN. So you just do a show IP interface brief or show interface brief. Okay. Here are some examples of some inter-VLAN routing problems. Then we'll talk about a little bit more in detail. You might want to look for some of this stuff to happen to you, say, on a final exam. So in this case here, let's see if we can make it a little smaller for you. That won't let me shrink it. Okay. So in this case here, you'll see we've got a trunk link going here to here. So my data can carry multiple VLANs here. Data can carry multiple VLANs here into the trunk. Okay. So VLAN 10 and VLAN 20 can go across both devices. And you'll also notice here I got VLAN 10, VLAN 20, and VLAN 99. And in the inter-VLAN connectivity issue, it could be caused by a missing VLAN. The VLAN could be missing if it was not created, if it was accidentally deleted, or if it's not allowed on a trunk line. Because by default, you allow all the VLANs to be on a trunk, but if you ran the allowed VLAN command, you may have missed one. Okay. Now assume VLAN 10 has actually been deleted. So we look here, we'll see that we have VLAN 1 and we have VLAN 20. And when you do a show VLAN, you'll see the ports that are assigned to each individual VLAN as well. You'll notice now that VLAN 10 is not missing from the output. Also notice that port F06 has not been reassigned to the default VLAN. And that's just right here. It goes 4, 5, okay, and 6 are missing. If 5 and 6 were on VLAN 10, you delete the VLAN 10, those ports do not automatically go back to VLAN 1. You would have to reassign them. They're technically still assigned to VLAN 1. I see that a lot of times when we are working in our labs and somebody would go in and delete the VLANs out of the system, but they don't reassign the ports back to VLAN 1. So you would have to manually go in and reassign them back to VLAN 1. You could use the show interface and then put the interface ID switch port command to VLAN membership. You could do a show run that will also show you where they are. Okay. Recreate the missing VLAN would automatically reassign the host to it. So if you set if you did a interface FA0/6 and then you the switch port access VLAN 10, it would automatically create VLAN 10 and assign 6 right back to it. Or if you just did VLAN 10 and you created your VLAN, it would work that way also. So other switch port issues we could have for inter-VLAN routing, if you have a misconfigured switch port. So in a legacy inter-VLAN solution, it'd be caused when connecting a router port that's connected that's not assigned to the correct VLAN. However, with router on a stick, the cause is usually a misconfigured port. So if you're looking at the example here, PC PC1 was able to connect to host and other VLANs until recently. A quick look at the maintenance logs revealed that the S1 switch 1 layer 2 switch was recently accessed for routine maintenance. Therefore, you might think that the problem will be related back to that switch. Okay. So we would go in, we do a show interface trunk, and you'll notice that we have FA01 is in trunking mode. The VLANs allowed in the trunk are 1 through 4094. But you'll also notice that port 5 on switch 1 is also a trunk port. So we have this one taken care of, but this one here is not being taken care of. So we would have to go to show running config, interface FA05, and you'll see that somehow during the maintenance uplink, the switch 5 is no longer a trunk. So it brought the switch port trunk up, okay, because it was down, and it automatically became a trunk again, and we were able to communicate back to the routers. Switch port accessing issues. When a problem is suspected with a switch access port configuration, you want to use your verification commands to examine the configuration and identify that problem. So once again, assume PC1 has a correct IPv4 addressing and gateway. It is unable to ping its own gateway. Okay? PC1 is supposed to be connected to VLAN 10. So therefore, its gateway would be 10.1. We do a show interface FA06. That is where PC1 is plugged into switch 1. You'll see the switch port is enabled. And it is trunk, so and it's been configured as an access port. However, it appears it has not been configured to VLAN 10. Okay, it's just an access port. It is not a VLAN 10 port. So you do a switch port mode, right? If you take a look at its interface, it says switch port mode is access, when it should be switch port mode access VLAN 10. Once we run that command, as you can see here, switch port access VLAN 10, PC1 is now back on 10 and will be able to hit its own gateway. Another routing on a stick problem that you might have would be related to sub-interfaces. So for example, an incorrect IP address was configured on the wrong VLAN ID and assigned to the sub-interface. Some of you saw that in your troubleshooting labs. Okay. So here you verified the switch trunk link and all appears to be in order. You verified the sub-interface status using the show IP interface brief command on the router. And you see you've got 192.10.1, 20.1, and 99.1, and that they are up and up on those sub interfaces. Then you verify which VLANs each of the interfaces is on. Okay. To do so, you do a show interface command. Useful, but it generates a great deal of additional unrequired output. Here you can use the pipe symbol along with some select keywords to help filter out the command. So in this example, the keyword include, okay, is used to identify that only lines containing the letters gig or 802.1q will be displayed because of the way the show interface output is naturally listed. Using these filters produces a condensed list of interfaces. So in this case here, we did show interface and use the pipe command. For those of you who don't know where that is the shift right above the enter key. Okay, and you want to include the phrase gig and 802.1q. So here's where it says gig, okay? And 801Q is where you can see where everybody was assigned to the appropriate VLANs. You'll notice, okay, that the G01.10 interface has been incorrectly assigned to VLAN 100 instead of VLAN 10. This is confirmed by looking at the configuration on router 1 and the .10 subinterface, as you can see. Your job, go in, interface gigabit G0/0.1.10, description, default, and then you do encapsulation .1Q, type 10, and it'll fix it right there. Next thing we want to talk about here is troubleshooting wireless LAN issues. We learned about troubleshooting, basic troubleshooting commands. We learned about troubleshooting routing on a stick. Now we're going to look at troubleshooting the wireless LAN. As always, standard 6 problems steps right there. Identify the problem, establish a theory, test it, plan of action to resolve, verify the functionality of the system. Don't forget to make sure the customer is happy too, and then document. Okay. So here we are. Wireless client is not connecting. So when you're troubleshooting that LAN, you have to come up with a process of elimination. In this figure here, okay, a wireless client is not connecting to the LAN. Just one wireless client is not connecting to the LAN. This guy's getting on, but this guy is not. That's important to understand. So it's not that the whole network's down, just one unhappy customer, which is one too many. Okay, confirm the network configuration on the PC using the ipconfig command. Verify that the PC has received an IP address via DHCP or is configured with a static. Confirm that the device can connect to the wired network. If necessary, reload drivers. If the wireless NIC of the client is working, check the security mode and encryption settings of the client. If the PC is operational but the wireless connection is performing poorly, okay, then you want to check how far is the PC from the AP. Is the PC out of the coverage area? Check the channel settings on the wireless client. The client software should detect the appropriate channel as long as the SSID is correct. Check for the presence of other devices in the area that may be interfering with the 2.4 gigahertz band. Things like cordless phones, baby monitors, your microwave ovens, security cams, maybe even a rogue AP. Next, you want to ensure that all the devices are actually in place. Consider a possible physical security issue. Is there power to all devices and are they powered on? Finally, inspect the links between the cable devices, looking for bad connectors or maybe a damaged or missing cable. The cable plan is in place, and you want to verify the wired LAN by pinging devices, including pinging the access point. If connectivity still fails at this point, perhaps something is wrong with the AP or its configuration. When the user PC is eliminated as the source of the problem and the physical status of the device is confirmed, now you want to start investigating performance of the access point. Okay, make sure it's powered on. Okay. If your wireless network is running slow, okay, to optimize and increase the bandwidth, you want to use dual band routers and access points. Upgrade your wireless client from if it's B or G, okay, or even N. Okay, devices can slow the entire wireless LAN. For best performance, all wireless devices should support the same highest acceptable standard. But what you don't want to have is if I have an old laptop that's running wireless G, which is only half duplex, it's going to bring down the rest of the network because now they're not running a full duplex. Although 802.11 AX and AC was released, okay, or AX was released in 2019, AC is most likely the highest standard that most enterprises are currently enforcing. Split the traffic. Easiest way to improve wireless performance is to split traffic between N 2.4 and the 5 gigahertz. Therefore, The 802.11, or the better one, can use the two bands as two separate wireless networks to help manage the traffic. So, for example, the 2.4 gigahertz network for basic network tasks such as web browsing, email, and downloads. And then for your media streaming and multimedia, you can use the 5 gigahertz network. Okay. There are several reasons for using that split traffic approach. 2.4 gigahertz band may be suitable for basic internet traffic. That might not be time sensitive. The bandwidth may be shared with other nearby wireless LANs. And the 5 gigahertz band is much less crowded than 2.4. Remember, 5 gigahertz band though does not. Although it's a more powerful and stronger band, it doesn't seem to go as far as the 2.4. By default, dual band routers and APs use the same network name on both 2.4 and 5 gigahertz bands. The simplest way to segment traffic is to rename one. Make one 2.4, make one 5. Like put it in their name, so you separate them by SSID. To improve the range of a wireless network, ensure that the wireless router or AP location is free of obstructions. I mean, seriously, furniture, fixtures, tall appliances, all those block the signal. You don't want your satellites to be more than 2 rooms away in many cases. Wi-Fi range extenders can help, but one of the problems we find with Wi-Fi range extenders, they fail quickly over time, even with the expensive ones, and they typically have a separate name. Okay, if need be, update firmware. Most wireless routers and APs offer upgradable firmware. Firmware releases may contain fixes for common problems reported by customers. Most of your wireless devices today will go out and update firmware automatically. Okay? And we didn't cover wireless controllers in this class, so I'm going to end the troubleshooting chapter there. That'll give you guys something to ponder and think about. And I want you to be on the lookout for some troubleshooting activities in your final exam. And that'll be everything.